Now in recent years, they like to combine area, bounded area, okay, in under integration, application or integration, they like to combine this topic with tangent normal. Okay, so you need to know tangent normal, okay, can be combined with this. But let's take a look at this question. The diagram shows part of the curve y equals to x cubed plus 3x squared minus 2. So this is the curve. The straight line L, so they label here L, cuts the curve at A, so this point labeled there for you, B, which is on the x-axis. So once you know that this is the x-axis, you should know that the coordinates has to be, because it's at the x-axis, right? So it must have an x value, so the y value is 0. Okay? So you need to find the x value lah. And the x value you must know is definitely negative something. Later when you work out, right, you should get a negative value. You don't get a negative value, something must be wrong because this is on the left side. And intersects the curve again at C. So this is intersection of the curve and the line at C again. So intersect at 3 points, 1, 2, 3. Alright? The gradient of the tangent to the curve at B. The gradient of the tangent to the curve at B is minus 3. So you must read this question carefully. The gradient of the tangent to the curve, is it this line that they're talking about? No, they're not talking about this line, okay? They're talking about tangent to a curve. From your E-maths, you learn that it's a line that touches only one point on the curve, right? Okay, so this is the tangent. It is not the normal that they are talking about, okay? So this will be the normal, which is perpendicular to the tangent. Okay, so they are talking about this line. If you want, you can actually draw a line here and then label it minus 3. See, it makes sense, right? So this downward sloping line has to be minus 3. Okay, I'll just leave this ruler here. Alright, use it to find the coordinates of B. Okay, so how do I use this to find coordinates of B? So you know that when you differentiate the y with respect to x, that means you find dy dx, you're finding the formula for gradient of the tangent. Okay, so when I differentiate this, I get this, right? And this gradient, they tell me is equals to minus 3 at this point B. So I equate it to minus 3, and from here I solve this equation. I get one answer, x equals minus 1. Then I already know from just now the y value is 0. So the point is minus 1, 0. So that's part 1 done already, 3 marks. Okay, now part 2 is the main focus of my video. They want you to find the area of the shaded region. Okay, so nothing to do with tangent normal already. Okay, I already know this point. Okay, and they say hence. So they're actually trying to tell you, hey, we ask you to find this point so that you can solve this part of the question. Okay, so how do I use this point, which is minus 3, 0, to solve this part? So let's go back to the basics. In order to find this shaded area, bounded area, plus this shaded area, you must understand that when you imagine yourself walking here, this top part, which I call the heaven, remains the same throughout, right? And this bottom part, which I call the earth, remains throughout. So as you walk from this point to this point, your heaven and your earth remains the same. Okay, so what you need to do is to integrate from minus 3, which is this fella here, minus 3, okay, integrate minus 3, all the way to, I made a mistake. Sorry, wait, what is the, oh sorry, minus 1, sorry, I see wrongly, minus 1, I calculated, no wonder, something seems wrong. Okay, it's minus 1, okay, I wrote wrongly, I saw this as minus 3, just now, so sorry about that. Okay, I know something is wrong because minus 3, I cannot integrate from minus 3 to minus 3, so it has to be a bigger number, right? So minus 1 makes sense. So minus 3, integrate minus 3 to minus 1, okay? and it must be the heaven, which is the curve, minus the earth, which is the line. At this point in time, right, when I was doing the question, I didn't realize that I had to do this. That's why you see I squeezed the solution here, but you could have squeezed it anywhere else. You see so much space left over for me, and then put a circle like me, and then later you draw lines, okay, draw lines back to here. Now I realized that I need to find the equation of this line. And how do I do that? I got this point, this point. If this is E max, find the gradient of AB. Find the gradient of AB, and then use any point on this line. And in this case, I use -3, -2. Okay, and I found the answer for the line, equation of the line now. So equation of this line is y equals x plus 1. So x plus 1, that's your earth. Alright, so that would be the area for this part here, plus now it's from here to here, so it's -1, integrate from -1 to 0, x equals 0. So these are the x values, because you're integrating with respect to x. Okay, and what's my heaven now? Now imagine you're walking here, the top is always the same, the bottom is always the same, right? So the heaven and the earth is always the same. And in this case, my heaven is not this line, not this line anymore, it's this line. And what's the equation of this line? It's actually the x-axis, which is actually y equals to 0. So it's actually 0 minus this earth. Okay, so some of you may have learned in tuition that, your tuition teacher might have told you, if it's under the graph, if it's under the x-axis, right, you change all the sign. Your tuition teacher might have told you that. The reason for that, right, is because you actually take the y equals 0, okay, minus the earth. That's the reason why you change all the sign. Alright, so I'm doing a very general method which works for all questions. Okay, so you do this carefully, you will be able to get the answer. Now some of you may take a few times in order to get the answer, because you might make careless mistakes here and there. Okay, so you need to practice. Alright,